Welcome back to the channel. This is the Maths DJ. Today we're going to be discussing how to use Euler's method for solving a differential equation on a CAS calculator. Just to give you a bit of background knowledge about Euler's method, it's a numerical method for approximating the solution curve associated with a particular initial condition. It generates points on the solution curve that we can join by sketching an approximate curve. It is an iterative process and it can be summarized as follows. So if our differential equation dy dx could be a function of x and y, and our initial conditions are x0 and y0, then the iterative process for solving the dE is highlighted in blue here. So it's yn plus 1 equals yn plus h, all multiplied by our derivative function, where xn plus 1 equals xn plus h, and h is our step size. So today we're going to focus on just using a CAS calculator. So Euler's method can be done on a CAS calculator, and the following template must be used. So we must type the word Euler and open a bracket, and then inside this command we have to firstly write the derivative expression, comma, then the independent variable, comma, the dependent variable, comma, and in a set of braces we have to input the initial condition for x, so x0, comma, and then the maximum value of x, comma, then we have the initial condition for y, so y0, comma, the step size. Or more simply, we type the word Euler, open a bracket, we write the derivative expression, comma, x, comma, y, comma, in braces, x0 to x max, comma, y0, comma, step size. So the output of this calculator will actually be a matrix, and it's important to know how to interpret the matrix that you get as the output. So basically, as you can see here, the first row of numbers in the matrix are the values for x, so x0, x1, x2, x3, all the way up to our x max, and the second row of numbers represent the corresponding y values, and they're the solutions that we're after. So the first number in the second row will be y0, then followed by y1, y2, y3, etc. So let's look at some examples and how we can use our CAS to determine the solution. So we have Euler's method with a step size of 0.1 is used to solve the differential equation dy dx equals e to the power of negative x, and the initial condition is y1 at x equals 2. The question is, when x equals 2.2, the value obtained for y, corrected 4 decimal places, is one of these 4 options. Okay, so using our CAS calculator, we type the word Euler, open a bracket, we input the derivative expression, so which is e to the power of negative x, followed by comma, x, comma, y, comma. Now in a set of braces, we put x0, so reading the question again, x0 is 2, comma, and x maximum is 2.2. Outside of the braces, then we do comma, the initial condition for y, which is 1, comma, and followed by the step size, so 0.1. Okay, so that's here on the left side of the screen, how we would input that into a CAS calculator. We press enter, and we have the corresponding values on the screen. So reading the question again, it says when x is 2.2, the value of y is. So looking at the matrix here, we can locate the value of x equals 2.2, and below that is the corresponding value of y. So to 4 decimal places, that would be 1.0258, which when we look at the questions here, that would be the answer of D, 1.0258. So next question. Use Euler's method with a step size of 0.1 to approximate the solution of the differential equation 1 divided by y multiplied by dy dx equals cos x, where y equals 2 when x equals 0. They're our initial conditions. And the question says when x equals 0.2, the value obtained for y, correct to 4 decimal places, is one of these 5 options here. Okay, so moving over to our CAS, we type the word Euler, followed by the expression for the derivative. So when we look at the question again, we will actually need to multiply both sides by y. So we would have dy dx equals y multiplied by cos x. So I can input that as our derivative expression, comma x, comma y, comma, open our braces up, put the value of x naught first, which is 0, comma, now x maximum, we're finding the solution when x equals 0.2, so the x max is 0.2, moving out of the braces, comma, the initial value of y, which is 2, comma, the step size, which is 0.1. Okay, so we have our matrix, and again, the question is, when x equals 0.2, what's the value of y? So we can see that on our screen. We look for x equals 0.2, look directly below that. There's the solution for y, and correct to 4 decimal places, that would be 2.4189, which is again an answer of D for this multiple choice question. And our last example here says, consider dy dx equals 2x squared plus x plus 1, where y of 1 equals y naught equals 2. Use Euler's method with a step size of 0.1. An approximation to y of 0.8 equals y2 is given by one of these 5 options. So here, again, on our CAS, type the word Euler, open a bracket, we write the derivative expression, so 2x squared plus x plus 1, comma x, comma y, comma, now open up some braces. Now we need to read this question very carefully. The initial condition for x is 1, y of 1 equals 2. So x is 1, and we need to figure out where we want to find the solution. What x value do we want to find the solution for? So if we read this question really carefully, it says find an approximation to y2, but y2 occurs when x equals 0.8. So x max is 0.8. Moving out of the braces, comma, the initial condition for y is 2, comma. Now the step size, the question says the step size of 0.1. However, we need to be extremely careful because the value of x is decreasing. The initial value of x is 1. We're trying to find a solution at x equals 0.8. So when we input the step size, we need to make that a negative. So we go down. We subtract the 0.1. We go from 1 down to 0.9 and then finally down to 0.8. If we forget the negative here, you'll end up with an incorrect answer. So step size in this particular example is negative 0.1. We hit enter. Okay, so looking at the matrix, we can see that x is stepping down by 0.1 from 1 to 0.9 to 0.8, and we are asked to find the solution when x equals 0.8. So we can look at the y value directly below the number 0.8 in the matrix, and we end up with 1.248, and in this case is B. So hopefully that's been insightful for you and given you some tips on how to use your CAS calculator to use Euler's method to solve a differential